Hello everyone, I'm Han Song, and now let's start with the question 1. So first, let's use the first method to do the question. Firstly, f c of c equals the integration in this dz region. It is the region of dz equals to x plus y is less than z of x fxy dx dy, and this one will equals to first minus infinity to infinity, and it is minus infinity to z minus x, just transferred from this one of fxy, and this will be dy dx, and this one will also equals to minus infinity to infinity, minus infinity to z minus y fxy dx dy, and the density function of z will equals to the dfz over dz, the derivation, and this is equal to d of dz minus infinity to infinity minus infinity z minus x fxy dy dx, just this one. So, and this will equals to minus infinity to infinity, just move this one to here, and d minus infinity z minus x fxy dy over dz dx. And then this one will becomes minus infinity to infinity f x z minus x and dx, according to some formula we can get this one, and this one is also equals to minus infinity to infinity f z minus y dy, and since fx and fy are independent, so minus infinity to infinity of fx z minus x dx will equals to minus fx to dx fx times fz minus x dx, and this is also equal to minus infinity to infinity of fz minus y x, and here is x, here is y, times fy of y dy. And according to this one and this one, we know that they're convolution, so this one is equal to fx of z fy of z. Second, let's use the second question. Since f the distribution function of z equals to x plus y is less than equal to z of x y dx dy. This one will equals to the integration of x y times f of x y times u of z minus x plus y dx dy. Since x plus y is less than equal to z, so x and y cannot be larger than z. And from this one, we can get a minus infinity to infinity, a minus integration of minus infinity of f(x,y) of u of z minus y minus x dx dy. This one is equal to this one. We just have change their orders, and this one can be equal to minus infinity to infinity, minus infinity. Since the upper limit of x is z minus y according to this, and so we can get the integration from minus infinity to z minus y of xy dx dy. And the density function of z of x will equals to d f(z) of z of dz. And this one will equals to we can put the first integration on the outside, and will become d minus infinity to z minus y f x y dx over dz times dy. And this one will equals to minus infinity to infinity to f z minus y and dy. Since we know fx and fy are independent, so according to this one, we can get this one equals to the integration from minus infinity to infinity of fx z minus y times fy of y dy. And this one is also equal to the convolution of fz, here x, now let's get the same result with this result, and this is the two method to get the fz, the density function, probability density function.